A mole is a SI unit to measure the amount of a substance. Remember, SI unit is the standard unit that we use for the metric system. Since it measures any amount of substance, 1 mole of anything can equal 1 dozen eggs, but it could also equal to 1 egg. 1 mole can also equal to 1.0079 grams of hydrogen. It could equal to 2.0158 grams of H2. In general, we are going to use the mole in 4 different conversion factors for stoichiometry. The first one is called molar mass. Molar mass tells you 1 mole of X. X could be an element, compound, molecule, is equal to its mass in grams, and we get this mass off the periodic table. If I say I have 1 mole of oxygen atoms, this is going to equal to 16.00 grams off the periodic table. But if I say I have 1 mole of O2, that's going to be 32 grams of O2 off the periodic table. So here we have 1 atom. So if I read it off the periodic table, it's 16 grams. Here I have 2 oxygens, so this is going to be 32 grams of O2. So it's 2 times 16. So let's look at the following. Sucrose is a sugar that you used in biology. Sucrose formula is C12H22O11. Since it has 12 carbons, we find a mass of 1 carbon off the periodic table, which is 12.01 grams, and we multiply by 12. So there's 144.12 grams of carbon in sucrose. Repeat the procedure for hydrogen. Hydrogen, there's 22 hydrogen atoms in sucrose. So the mass of hydrogen off the periodic table is 1.01 grams. We multiply by 22 and we get 22.22 grams. Oxygen, there are 11 oxygens in sucrose. The mass of 1 atom of oxygen is 16.00. We multiply by 11 and we get 176.00 grams. To find the molar mass or the molecular mass, you add all the masses of all the atoms in sucrose. So we have 144.12 grams of carbon, we have 22.22 grams of hydrogen, and we have 176.00 grams of oxygen. If we add this up, we get approximately 342.34 grams of sucrose. Find that the molar mass of 1 mole of sucrose is equal to 342.34 grams of sucrose. And where did we get the numbers? We got those off the periodic table. So molar mass becomes a conversion factor. So 1 mole of something is equal to its gram of something. We will spend more time on this concept when I go through the 4 different types of conversion factor in video 3. Percent composition. Percent composition is the mass percent of each element in a compound. If we have water, H2O, we will find the percent of hydrogen in the water compound and the percent of oxygen in the water compound. H2O is 1 full compound. The total percentages must equal or add up to 100%. You already know how to do percent composition. This is how grades are calculated. It is always a part to a whole number times 100. So for example, if you have an 80% and the test was out of 100 points, that means the whole is 100 points and the part that you got right is 80 points. Times 100, this is how we get 80%. So we're going to do the same thing, but we're going to use elements. So if I need to find element X, it's going to be the mass of that element X over the total mass of the compound times 100. For example, when we had water, the mass percent of hydrogen is going to be mass of hydrogen divided by the total mass of water times 100. Since there are 2 hydrogen atoms, we need to do 2 times hydrogen divided by the total mass of water times 100. Let's look at this first example, dinitrogen disulfide. So we need to find the percent composition of nitrogen and sulfur. So general formula is percent X is equal to the mass of X over total mass of compound times 100. So we're going to find the total mass first. So for nitrogen, there's 2 nitrogens. So each nitrogen is 14.01 grams. So the total mass of 2 nitrogen is going to be 28.02 grams. So for sulfur, we have 2, and each sulfur is 32.01 grams. So this is going to equal to 64.02 grams. So if I add the 2, that would give me the total mass, which is 92.04 grams. This is the total mass of the compound. So to find the percent of nitrogen, this is going to be the mass of nitrogen over the total mass times 100. The mass of nitrogen, there's more than 1, is going to be 2 times 14.01 grams. We know that is 28.02 grams over 92.04 grams times 100. This is going to equal to 30.44%. Percent composition, there is no sig fix, just carry 2 to 3 digits after the decimal. So we're going to redo it for sulfur. So that's going to be the mass of sulfur over total mass times 100. This is going to be 64.02 grams divided by 92.04 grams times 100. And we get 69.56%. So in dinitrogen, disulfide, we have 30% that is nitrogen and 69% that is sulfur. Once you solve for nitrogen, the other way we could solve for sulfur, nitrogen, sulfur adds up to 100%. If we know the percent of one of the compounds, we could solve for the other compound by subtracting from 100. So the other way we could solve for percent of sulfur is going to be 100% minus the percent of nitrogen, and this will be 100% minus 30.44%. Pause the video. Solve for the mass percent of each element in iron 3 sulfate and then check your answer. To find the percent of each element, we know it's percent X equals to mass of X divided by total mass times 100. So here we need to find the percent of iron. So that's going to be mass of iron divided by total mass of the compound times 100. We can do the same thing for sulfur, which is the mass of sulfur over the total mass times 100. And then percent of oxygen is going to be mass of oxygen over the total mass times 100. So we need to find the total mass. So there are 2 irons because there's a subscript next to Fe. There are 3 sulfurs because the 3 is outside the parentheses, so there's 3 sulfate. And then there's 12 oxygen because 4 times 3 is 12. Each iron has a mass of 55.85 grams. We need to multiply by 2 because there's 2 of them. This is 111.7 grams. There are 3 sulfurs. Each sulfur is 32.07 grams, which equals 96.21 grams. There are 12 oxygen, which each weighs 16 grams. This is equal to 192.00 grams. If I add all of this up, the molar mass is 399.91 grams. So again, the mass of irons, there's 2 of them, so you have to do 2 times 55.85 grams over 399.91 grams times 100. This equals to 27.93%. Again, for percent composition, we are not doing sig figs, just carry 2 to 3 digits after the decimal. So for sulfur, there are 3 sulfurs, each weighing 32.07 grams over the total, 399.91 gram times 100. This equals to 24.06% sulfur. Oxygen, There are 12 of them, so 12 times 16.00 grams. Divide by the total, 399.91 gram, times 100. This equals to 48.01 grams of oxygen. So the other way we could have solved for oxygen, the total must equal to 100. So I could add the iron and sulfur and subtract from 100, and I will get approximately 48.01 grams of oxygen. So percent composition is the mass of the element. Make sure you have the total mass of the element. So for example, iron, we can't just say one iron when there are two irons. So the total mass would be 2 times the mass of the iron. Divide by the total mass times 100.